Hi guys, today we're going to go over chapter 7.1, Slope-Intercept form. So the equation of a non-vertical straight line graph can be written in the slope-intercept form. And you guys are aware of this equation, and you probably learned this in grade 9. And we're going to talk about why this is called slope-intercept form. First of all, last class, we talked about what that M stands for. M stands for slope, and something new here today, B stands for Y-intercept. So we know slope M represents rise over run, and Y-intercept is a point where the line crosses the y-axis. Let me give you an example on that. Let's say we have x-axis here and y-axis here, and our function is a straight line that goes this way. Notice that this point here crosses the y-axis. Let's say that point is 0, 2. At 0, 2, this is where y-intercept happens. So this is y-intercept because it goes through y-axis. So B is a variable for y-intercept. So let's take a look at example 1. So write the equation of each line in slope-intercept form. So we're looking for y equals mx plus b form. Alright, so here's your step. Step number 1 is to find 2 points on the line. So we want to look for nice points like that gives us integer values. For example, this one here, let's say that's 0.1. It's a nice number that goes right on the tip here. And let's say my graph is not the best, but this point will do. Let's say that's P2. P stands for points, first point and second point. So we know P1, the coordinate is 0 and -3. And point 2 is 11 and 3. So once we are done with step 1, we can move on to step 2. Step 2 is to find slope. We have the formula for slope, y2 minus y1 over x2 minus x1 from previous section. So all we have to do is match the ones. For example, this is x2, y2, x1, y1. Okay, so we're going to match it. So this goes here. This goes here. This goes here. And then lastly, this one right here. So all we're doing is substituting. So y2 is 3, y1 is -3, so you're minusing -3. And then x2 is 11, we minus x1, which is 0. So this just turns out to be 6 over 11. Step number 3 is to find y-intercept. So y-intercept is when the line crosses the y-axis here. So this is x-axis and this is y-axis. So a point that we can find that's on the y-axis is y-intercept. So P1 is y-intercept. Okay, so we know y-intercept is 0 and -3. So B equals -3. Step number 4 is to plug in all these variables into the equation. So we have y equals mx plus b, and all we have to do is sub in, so y equals, sub in the slope, which is 6/11 x, and then we add the b here, so -3. Either this, or we can say, or y equals 6/11x minus 3. So you can drop the positive sign if you're adding a negative number. Moving on to part B. This time we have a horizontal line as a function. So let's take a look. So we're going to follow the first step. So first step was to find the 2 points. So I like my point, let's say, I guess it doesn't matter here. So they're all nice integer values. So I'll say P1 here and P2 here. So P1, the coordinate is 1, 2, 3, 4, 5, 6, 7, -7, and 1, 2, 3, 4, 5, 6, 7. So the coordinate is -7 and 7. And P2 is 0 and 7. And then second step is to find the slope. What is the slope of a horizontal line? Slope, by definition, is change in y over change in x. But there's no change in y. It doesn't go up or down. It doesn't go up or down here. It only goes left to right. So we can say that change in y is 0 and x is 1, so step 7. So difference is 7. So this just means the slope equals 0. Next thing to consider is a y-intercept. Y-intercept is a point on a line that crosses a y-axis, which happens to be P2. So y-intercept happens at 0 and 7. Therefore, b equals 7. Fourth step is to plug these values into the equation y equals mx plus b. Y equals, slope is 0, and then b is positive 7. Notice that 0 times x is 0, so we're left with just 7 on the right-hand side. So y equals 7. Now moving on to next example. Same steps, we'll pick 2 points on this line. So I like my point here, and I'll choose this point as point 1. So P1 and P2. So the coordinate of P1 is -4 and 4. Coordinate for P2 is -4 and 0. By the way, notice that this point from the previous example, this was y-intercept. But this time, what we see here, because this is an x-axis, this is called x-intercept. To step number 2, we're trying to find slope. Slope is delta y over delta x, so change, like the rise over run. So the rise, in this case, from point 1 to 2 was 1, 2, 3, 4. So it was 4 down. So we can say delta y is -4. But was there any horizontal changes? No. So delta x is 0. Notice that when you divide any number by 0, this value becomes undefined. So slope is undefined. That's really weird, isn't it? So let's take a look at y-intercept as well. Is there any point that crosses a y-intercept here? This is a y-intercept. Unfortunately, we have our line this way, and this will never ever touch y-axis. So there's no y-intercept. No y-int. All right, so our equation is going to be quite interesting one. So this notation, by the way, is therefore. So therefore, we have x equals to -4 as an equation of a line. Now example 2. Draw the graph of the following equations. Part A, this is the equation in slope-intercept form. What we're going to do is we're going to follow the step to draw the line. So step 1 is to plot y-intercept. Notice that we are given what slope is and what y-intercept is. This is slope, this time slope, and y-intercept. So y-intercept is at 0 and 7. So this is x-axis and y-axis. So x equals 0, y 7. So 1, 2, 3, 4, 5 here. And so 7's right here. So this is our point. Step 2 is to complete the pattern by following slope. So complete the pattern. So when slope equals -3, we know right away we have that over 1, but we just don't write it. So the numerator indicates that the point is going to go down 3 and then 1 to the right. So we're going to continue this pattern here. So let's see, from that y-intercept point, we go down 1, 2, 3, and then 1 to the right. So our point is right here. Next point will be 3 down and 1 right. 3 down and 1 right. 3 down and 1 right. And you continue the pattern, and you can also go backwards this way as well. Okay, so it is possible to go both ways. So let's connect the points here. That's good enough, so we'll stop right there. All right, so you draw the arrows at the end as well. So we have our equation y equals to -4/3x plus 1. So notice from last class, we have used this form. This is called slope-intercept form of a line. Okay, so y-intercept is b, and m stands for slope. So what we can state here is that our slope from our equation is -4/3, and y-intercept b is 1. This -4 indicates that we're going 4 down, and this denominator indicates we're going 3 to the right. Last class we said that we need to find or plot the y-intercept first, so we're going to do that first as well. B equals 1, so this is y-axis, so right here, this is y-intercept, and we're going to go 4 down, 1, 2, 3, 4, and then 3 to the right, 1, 2, 3. just like that, and you continue the pattern this way. You can also go backwards by counting the opposite side. So we're going 4 up, 1, 2, 3, 4, and 3 to the left, 1, 2, 3. So we can get this, and we will connect the points. Something like that. All right, so that's it for example 2, part C. Moving on to example 3. The speed of sound at 0 degrees Celsius is 331 meters per second. At 15 degrees Celsius, the speed increases to 340 meters per second. Part A tells us to draw a graph representing this data. So what we need to first see is that the given information is the temperature and the speed. The temperature and another speed here. Our graph is going to be something to do with temperature and speed. So normally, you would first need to write a point. For example, point 1, the first data point we can use is this property. So at temperature equal to 0, speed is 331. For point 2, when temperature is 15 degrees Celsius, the speed is 340 meters per second. Now we're going to graph these 2 points. So our independent variable is going to be the temperature, and speed is the dependent variable. All right, so this time I actually would like to use a break in the graph. So break looks something like this. So this indicates there's a jump in the increments. So this is called break. Can start with 300. So let me paste this over here. So if I start at 300 here, and it's going up by 5 now. So this is why we could actually use the break to stretch this values up a bit so we can easily graph. All right, so let's take a look at when temperature equals 0, and then we go up by 5 here, and 10 here, and then 15 here. So for temperature, we're going up by 1. So when temperature equals 0, speed is 331. So at 0, 331 here. P2, when temperature is 15 degrees Celsius, speed is 340, so we can just plug it here. And then we could, oh, maybe not. I could draw a straight line going through that point. And also we can technically go backwards as well. I just didn't have the grid set up for it, but yeah. So let's take a look at part B. Write an equation for the speed of sound as a function of temperature. So we have 2 things here. Speed of sound as a function of temperature. So function of temperature means, so speed is going to be a function in terms of temperature T. So let's say S for speed and T for temperature. Now we can set up our function notation. So S in terms of T equals m, the slope, times the independent variable T plus B, which is Y-intercept. So this is just from Y equals mx plus B form. We're just replacing the variables. Let's first note what slope is in this case. So slope in this, with using those 2 points, we have to use y2 minus y1 over x2 minus x1. And also for B, we can use this point instead. P1 because this point on a grid is touching the y-axis. So that is, this is a y-intercept. So we'll take the y value, 331 as b. All right, so we get slope equals 340 minus 331 all over 15 minus 0 times t plus 331, which simplifies to 3 over 5 times t plus 331. And don't forget the function notation. Moving on to part C, what is the speed of sound at 35 degrees Celsius? So this time we were given the temperature. So we're going to use a formula we just made. So S of t equals 3 over 5 t plus 331. And we're going to plug in the temperature value. So we have 3 over 5 times 35 degrees Celsius. We're subbing into t, and we're going to solve for speed at temperature equals 35. So this just turns out to be, actually here, I'll do by canceling, so 7 and 1. So we get 21 plus 331. At the end, we get 352. So because it is a word problem, we want to answer using full sentences. So speed of sound at 35 degrees Celsius is 352 meters per second. So do not forget the units. Same step for part D. At what temperature is the speed of sound 364 meters per second? So this time we were given speed. So we're looking for the temperature. So we're using S of t equals 3 over 5 t plus 331. And then we're going to plug in 364 into the left-hand side because now this time we know the speed. And we're looking for temperature T. Let's isolate T. We're going to subtract 331 on both sides. So we get 3 over 5t. Let me scroll up a little bit. And then we have 33 left on the left-hand side. And so we're going to multiply in order for me to get rid of that denominator 5, I'm going to multiply both sides by 5. So we're going to multiply both sides like this. And so we get 165 equals 3t. We need to isolate t by dividing both sides by 3. So we get 55 equals t. Therefore, the speed of sound is 364 meters per second at 55 degrees Celsius. Moving on to example 4. John is salesman earning $800 per week plus a 9% commission. So we're going to write an equation for John's earnings as a function of sales. So notice that earning, E, is going to be in a function of sale, S for sale. So E of S equals, what we need to know is that there's 9% commission based off of his sale and $800 per week as a flat earning. Okay, so we start at 800, that is the initial earning, and it goes up by 0.09 every sale he makes. So let me rephrase this. This is in terms of S, earning in terms of S, 800 is initial earning, And this 0.09 is commission. And S stands for sale. Let me rewrite this equation in the form that I like. So E equals 0.09 times S plus 800. I like this form because we're used to using y equals mx plus b. So I would like to have my slope in the front. So this is a slope, and this is b. So now we can graph. So first we need to define the axes here. So earning goes here, and sale is a horizontal axis here. So they both start at 0. I'm going to go up by 200. And you are free to choose other values. You're still going to get the same graph, but it might just look a little more, steeper or not. So don't worry too much if it doesn't look exactly like mine. All right, and for sale, I'm going to go up by 500. So 1,000 here, 1,500. All right, and so first, because we don't have the point to start, we can use the y-intercept here, which is 800. So 800 right here, this is the starting point, and we're going to go up by 0.09 over 1. The slope is really weird. So what you can do just pick a value like 2,500 and then for S and then plug it into E. Okay, so before we actually plot the rest, maybe we should take a look at part B. So if John sells $2,500 worth of product in a week, what does he earn? So we can just go plug in the S equal to 2,500. So 0.09 times 2,500 plus 800. And using your calculator, if you plug in that punch into your calculator, you get 225, and then you add 800. Altogether, it becomes 1,025. So earning is $1,025 if he sells $2,500 worth of product. So this is where we can actually define the coordinate. The coordinate of the second point is going to be the 2,500 and then y value is 1,025, like that. So we can actually graph this now. So this point is on sale 2,500 and it goes all the way up to 100 here-ish. Okay, and then you can actually just connect the points, just like that. And don't forget, for part B, we do have to state it in words as well. So John earns this much if he sells $2,500 worth of product. Part C is quite similar to part B. How much did John sell if he earned $1,016 in a week? So this time, this value we're given is earning, E. So using the general equation from previous sections, so E equals 0.09 S plus 800. We're going to go input that E value here. And we're going to isolate S. Okay, so step by step, so we subtract 800 on both sides. So we're left with 0.09 S on the right hand side, and the left hand side we have 216. And then we're going to divide both sides by 0.09 because we're trying to isolate S. So nothing should be in front of S. So if you actually punch into a calculator, you should get 2400 equals S. There's notations therefore. So therefore, John sold $2,400 worth of products to earn $1,016 a week. So that's it for 7.1. I'll see you guys in the next video.